Have you ever looked at some complex pattern in a program and just wondered, how did they do that with code? Well, a lot of the time, the secret is something surprisingly simple but incredibly powerful: the nested loop. So let's jump right in and demystify how putting a loop inside another loop can unlock a whole new world of creative coding.
So here's our game plan. We're going to start with the basics, what are these things? Then we'll peek under the hood to see how they actually work. After that, the fun really begins. We'll get our hands dirty and build a simple rectangle, and then level up to a pyramid. And we'll finish off by giving you a way to think in loops so you can tackle your own projects.
All right, first things first. Before we can start building cool shapes, we've got to nail down the fundamental idea. So what exactly is a nested loop?
Honestly, it's as simple as it sounds. You just take one loop and stick it right inside another one. That's it. The one on the outside becomes the outer loop, and, you guessed it, the one inside is the inner loop. This basic setup is a total game changer for tackling more complex problems. If you want a really great way to visualize this, just think of a regular analog clock. The minute hand has to go all the way around, a full 60-minute cycle, right? That's our inner loop running to completion. Only after it's done its entire job does the hour hand get to tick forward just once. That relationship is the absolute key to understanding nested loops.
Okay, so we've got the what, but now let's dig into the how. It's really important to get the flow of execution down, to see the dance between these two loops. This little flowchart shows it all perfectly. The program hits that outer loop, checks its condition, and if it's true, it dives into the inner loop. And here's the crucial part. It gets stuck in that inner loop. It will not leave until that inner loop's condition is false. Only then can it go all the way back up to the top and start the next round of the outer loop.
So let's break it down. For every single time the outer loop runs, the inner loop has to run completely from start to finish. It's like the outer loop starts its turn, then says, "Okay, inner loop, you're up," and just waits. The inner loop does its entire thing, and only when it's totally finished does it hand control back so the outer loop can move on to its next step.
All right, enough theory. Talk is cheap, right? Let's actually see this thing in action and build something real. We're going to start nice and easy by creating a simple rectangle made of stars.
And this is what we're aiming for: a nice, clean grid, 3 rows tall, 5 columns wide. This is the perfect job for a nested loop. Think about it. The outer loop can handle the rows, and for each of those rows, the inner loop can handle printing the 5 stars for the columns. And here's the code that'll make it happen. The first for loop, our outer one, runs 3 times for our 3 rows. Inside that, the second loop runs 5 times for the 5 columns. But look really closely at where the print statements are. The star gets printed inside the inner loop, but the command to go to a new line, that's outside the inner loop. That placement is everything. Let's trace it and see why.
Okay, let's walk through it. The outer loop starts, I is 1. Now it pauses. The inner loop takes over and runs 5 times, printing a star each time. 1, 2, 3, 4, 5. Bam, 5 stars are on the screen. The inner loop is done, so we finally hit that new line command, and our cursor drops down, ready for row 2.
So now control goes back to the outer loop. It increments, so I is now 2. And guess what happens? The exact same thing. The inner loop gets reset and does its full 5-star performance all over again, but this time on that new line we just created. And here comes the final pass. The outer loop sets I to 3. The inner loop does its job one last time, printing that final row of 5 stars. After that, the outer loop tries to become 4. Its condition is finally false, and the whole thing stops. And just like that, we've got a perfect rectangle.
Okay, the rectangle was a great start. But the real magic of nested loops happens when the inner loop's behavior actually depends on where the outer loop is. So let's level up our game and build a pyramid.
This is our new goal. You can see it's a bit more complex, right? Each row is different. It has a different number of empty spaces before the stars and a different number of stars. This means our inner loops need to be smarter. They have to be aware of which row the outer loop is currently building.
Now check out this code. We still have our main outer loop for the 5 rows. But now there are 2 inner loops. The first one handles the spaces, and look at its condition, 5 minus I. That means as I gets bigger, we print fewer spaces. The second one prints the stars, and its condition, 2 times I minus 1, means as I gets bigger, we print more stars.
Let's run the numbers. When I is 1, the space loop runs 5 minus 1 times, so 4 spaces.
The star loop runs 2 times 1 minus 1 times, just once. And there it is, the top of our pyramid. Then I becomes 2. We get 5 minus 2, which is 3 spaces, and 2 times 2 minus 1, which is 3 stars. See? The pattern is already forming.
And the logic just keeps chugging along. For row 3, we get 2 spaces, 5 stars. For row 4, just 1 space and 7 stars. You can really see the magic here. The value of I from that one outer loop is directly controlling how many times both of the inner loops run. That's how we get that perfect sloping shape.
On the final row, I is 5. The space loops condition, 5 minus 5, is 0, so it doesn't even run. No spaces get printed. But the star loop runs 2 times 5 minus 1, a full 9 times. And that creates the wide, solid base of our pyramid. And just like that, we're done.
Okay, so we've seen how to trace the code once it's written, but the real skill is figuring out how to write it in the first place. So let's talk about a framework, a way to approach any of these pattern problems.
Here's a process you can use every time. First, just look at the final pattern. Break it down. What's repeating row by row? That's your outer loop. Then, for each row, what's repeating inside it? Those are your inner loops. Figure out the conditions based on the row number, put your print statements in the right place, and then run it to see what you get. It turns a big, scary problem into a few small, manageable steps.
At the end of the day, nested loops are a core tool for creating things with code. They let you build complex structures from simple, repetitive rules. So take a look at these patterns. Try to apply that framework we just talked about. How would you handle the rows? What about the spaces and the numbers? Thinking through that process is how you really start to master this stuff.